Imagine waking up tomorrow and discovering that a completely new energy system has already started forming beneath the surface of the global economy. Factories are quietly installing massive machines that split water into hydrogen using renewable electricity. Industrial gas companies are expanding networks of pipelines, liquefaction plants, and storage facilities designed to move hydrogen across continents. Governments are writing regulations and subsidies around a molecule that could reshape heavy industry, shipping, fertilizer production, and global energy trade. And behind all of this activity are a handful of companies that most people rarely think about. Yet they are building the foundations of what many analysts believe could become one of the most important industrial transformations of the 21st century: the green hydrogen economy. Green hydrogen is often described as a simple idea. Use renewable electricity from solar, wind, or hydropower to run electrolyzers, machines that split water molecules into hydrogen and oxygen. Capture the hydrogen, compress or liquefy it, transport it through pipelines or tankers, and then use it as a fuel or industrial feedstock. But in reality, building a functioning green hydrogen economy is far more complicated than installing electrolyzers. It requires entire systems of infrastructure: electricity supply, water treatment, electrolyzer manufacturing, hydrogen compression, storage tanks, liquefaction facilities, transportation networks, fueling stations, and industrial customers capable of using hydrogen instead of fossil fuels. Creating all of these systems simultaneously is one of the most complex industrial engineering challenges currently underway in the global energy transition. The companies building this new hydrogen infrastructure do not all look the same. Some specialize in the machines that produce hydrogen. Others dominate the industrial gas networks that distribute it. Some are developing massive hydrogen production plants powered by renewable electricity, while others focus on transportation systems that move hydrogen from one region to another. When you look closely, you begin to see a layered industrial ecosystem forming around hydrogen technology. And at the center of this ecosystem are several companies whose strategies reveal how the green hydrogen economy might actually emerge. One of the most recognizable players is Plug Power. Plug Power began its journey not by producing hydrogen, but by building fuel cells designed to power forklifts and warehouses. These fuel cells allowed companies like Walmart and Amazon to replace battery-powered forklifts with hydrogen-powered systems that could refuel quickly and operate continuously. Over time, Plug Power realized that controlling hydrogen supply was just as important as building the fuel cells themselves. That realization led the company to pursue an ambitious strategy: constructing a vertically integrated green hydrogen network that includes electrolyzer manufacturing, hydrogen production plants, liquefaction facilities, distribution logistics, and fueling stations. Instead of simply selling equipment, Plug Power is attempting to build an entire hydrogen ecosystem that connects renewable electricity to industrial customers across the United States. The scale of this ambition is enormous. Plug Power has invested billions of dollars in hydrogen production plants located in regions with abundant renewable electricity. These plants use electrolyzers to convert renewable power into hydrogen, which is then liquefied and transported by tanker trucks to customers. The company's long-term vision involves creating a network of hydrogen hubs capable of supplying large industrial users, transportation fleets, and distribution centers. If this network works as intended, Plug Power would not just be a technology provider. It would become one of the core infrastructure operators of the hydrogen economy. But Plug Power is not the only company building the machines that produce hydrogen. Another key player is Nel ASA. Nel specializes in electrolyzers, the industrial systems that perform the electrolysis process itself. These machines are the heart of any hydrogen production facility. Nel has spent decades refining both alkaline electrolyzer technology and newer proton exchange membrane electrolyzers designed to operate efficiently with fluctuating renewable power. The company's strategy focuses on scaling manufacturing capacity, so electrolyzers can be produced at industrial volumes rather than small custom installations. By expanding factory production lines, Nel aims to drive down the cost of electrolyzers, which remains one of the biggest barriers to making green hydrogen competitive with hydrogen produced from natural gas. Another powerful force in the hydrogen industry comes from companies that have been producing industrial gases for more than a century. Firms like Liquide and Linde already operate enormous networks that produce, transport, and supply gases such as oxygen, nitrogen, and hydrogen to industries around the world. Long before green hydrogen became a political priority, these companies were building pipelines, storage facilities, and liquefaction plants designed to deliver hydrogen to refineries, chemical plants, and semiconductor factories. Today, they are applying that experience to the emerging green hydrogen market. For companies like Liquide and Linde, hydrogen is not just a futuristic energy carrier. It is a gas that must be managed with extremely sophisticated industrial infrastructure. Hydrogen molecules are tiny and prone to leakage. They require specialized compression equipment, cryogenic storage tanks, and pipelines designed to handle high pressures and low temperatures. Transporting hydrogen safely and efficiently is an engineering challenge that few companies in the world have mastered. That is precisely why industrial gas companies are so influential in the hydrogen economy. They possess decades of operational expertise in handling hydrogen at industrial scale. Another company making massive investments in hydrogen infrastructure is Air Products. Air Products is developing some of the largest hydrogen projects ever proposed, including multi-billion-dollar facilities designed to produce hydrogen from renewable electricity and convert it into ammonia for export. These projects aim to create global supply chains in which hydrogen-rich fuels can be shipped from regions with abundant renewable energy to industrial markets that need low-carbon fuels. If these projects succeed, hydrogen could become a globally traded commodity similar to liquefied natural gas. Technology providers are also playing an essential role in the hydrogen economy. Companies like Siemens Energy are developing advanced electrolyzer systems designed to integrate with renewable electricity grids. Siemens Energy has invested heavily in large-scale electrolyzer factories capable of producing gigawatts of hydrogen production equipment each year. The goal is to industrialize hydrogen technology so that hydrogen plants can be deployed rapidly as renewable electricity expands. Meanwhile, companies such as ITM Power focus on proton exchange membrane electrolyzers optimized for dynamic operation with wind and solar power. Renewable electricity is inherently variable, and hydrogen systems must be capable of adjusting production levels in response to changing electricity supply. Advanced electrolyzer technologies allow hydrogen plants to ramp production up or down, depending on renewable generation, turning hydrogen production into a flexible load for electricity grids. When you look at these companies collectively, an interesting pattern emerges. Each one controls a different piece of the hydrogen value chain. Some build the machines that produce hydrogen. Others manage the infrastructure that transports and stores it. Some specialize in fuel cells that convert hydrogen into electricity, while others develop massive industrial projects that supply hydrogen to chemical plants, steel mills, or transportation fleets. No single company controls the entire hydrogen system. Instead, the emerging hydrogen economy resembles a network of interconnected industrial capabilities. This network structure reveals something important about how large energy transitions actually occur. New energy systems rarely emerge from a single breakthrough technology. Instead, they arise when multiple industries simultaneously adapt their capabilities to support a new fuel or energy carrier. The green hydrogen economy is developing in precisely this way. Renewable electricity producers provide the power required for electrolysis. Electrolyzer manufacturers build the machines that generate hydrogen. Industrial gas companies handle storage and distribution. Engineering firms design the plants and pipelines. And industrial customers adopt hydrogen as a feedstock or fuel. The result is a slowly expanding ecosystem that connects electricity systems, industrial manufacturing, transportation networks, and global commodity markets. If this ecosystem continues to grow, hydrogen could eventually play a central role in decarbonizing sectors that are extremely difficult to electrify directly. Steel production, fertilizer manufacturing, shipping fuels, aviation fuels, and heavy industrial heat all represent potential markets for hydrogen-based energy carriers. Yet the success of this vision is far from guaranteed. Hydrogen remains expensive compared with fossil fuels in many applications. Electrolyzers require large amounts of electricity, and renewable power infrastructure must expand dramatically to supply that energy. Hydrogen storage and transportation systems are complex and capital-intensive. Building a fully functional hydrogen economy could take decades and trillions of dollars in investment. This uncertainty is precisely what makes the strategies of hydrogen companies so fascinating to observe. Firms like Plug Power are betting that early investments in infrastructure will position them as dominant suppliers once hydrogen demand begins to scale. Electrolyzer manufacturers like Nail and ITM Power are racing to reduce equipment costs through industrial manufacturing. Industrial gas companies such as Air Liquide, Linde, and Air Products are leveraging their operational expertise to build hydrogen supply networks capable of supporting entire industrial clusters. Each of these companies is effectively placing a strategic bet on the same long-term outcome. that hydrogen will become a major component of the future global energy system. If they are correct, the infrastructure being built today could form the backbone of a multi-trillion-dollar hydrogen economy. If they are wrong, billions of dollars in industrial investments could struggle to find profitable markets. From a systems perspective, what we are witnessing today is not merely the rise of a new fuel. It is the early construction of an entirely new industrial architecture connecting renewable electricity, chemical engineering, global logistics, and heavy industry. The companies involved in this transformation are not just developing technologies. They are building the physical systems that could determine how hydrogen moves through the global economy for decades to come. The question now is not whether hydrogen technology works. Electrolyzers, pipelines, liquefaction plants, and fuel cells have existed for years. The real question is whether all of these systems can be integrated into a coherent network that operates reliably and economically at massive scale. That integration challenge will ultimately determine whether the companies building the green hydrogen economy today are laying the foundations of a new industrial era or simply constructing the most ambitious energy experiment of the modern age. If you want to explore the real engineering, economics, and system challenges behind green hydrogen projects, you can dive deeper through the professional resources available through Renewable. These materials break down the real-world development process of hydrogen projects, from feasibility studies and financial modeling to infrastructure planning and project execution.